Hello, my name is Omar Hashimi, and in this video I'll be explaining a couple of topic 1, paper 1 questions, a couple of topic 1, paper 1 chemistry past paper questions, and the first one is this question code right here. I can't show the actual question due to copyright reasons, so yeah. This question asks, how many atoms are present in 0.1 moles of diamine dichloroplatinum? Now, diamine dichloroplatinum is this formula right here, and it wants us to find how many atoms are present in 0.10 moles of diamine dichloroplatinum. Now, first, we know that Avogadro's constant is 6.02 times 10 power 23. However, since this is paper 1, we can simplify this to just 6.0 times 10 power 23. Okay. So first things first, the question asks us to find how many atoms are present in 0.10 moles. So what we can do is we can find out how many atoms are present in each, in this formula. So here, this is one atom. This is 2 atoms of chlorine. And then this 2 is going to get distributed here and here. Then that's going to be 6 atoms of hydrogen and 2 of nitrogen, which in total is going to be 11 atoms. So using these 11 atoms, we need to find the number of moles. So right here, it wants us to find 0.10 moles. So each mole is 6.0 times 10 power 23. So we want to get 0.10 of that. So 6.0 times 0.1 times 10 power 23. Now since this is paper 1, there's no calculator. But if we do the math, times 0.1, we'll get 6, 0, 0, 0, and then we'll be left with 0.60. And then taking that, we can multiply it by the 11 atoms times 10 times 11. We'll be left with 0 and 6, and then 0, 0, 6. Add these, we'll get 6.6, and then multiply that by Avogadro's, because that's the number of atoms, which is then times 10 power 23, and that would be our answer. Alright, now for the next question, the question code is listed above, asks, what is the balanced whole number ratio of the coefficients of ammonia to oxygen when the following equation is balanced correctly? Now, to do this, I made this nifty little table here that you can use where any values of each element can be placed on either the reactants and the products, and we have to make all of them equal. So for example, the N on the reactant side is 1, and on the product side is 1. So check. Now, the O is 2 on the reactant side and 2 on the product side, so that is correct. However, here, the hydrogen is 3 on the product side, on the reactant side, sorry, and 2 on the product side. Now this is what we need to fix. So to do this, we'll put a coefficient of 3 here, a coefficient of 2 here, and this will make both hydrogens 6. Now, because of that, the N has changed and it has become 2 on this side. And what we'll have to do is we'll have to keep changing the coefficients in order to match the in order to make all of the elements match on both sides. And there we go. Now that all of them are equal, since all of them are equal, we can now take these, because that's what the question asks for. It asks for the coefficients of ammonia to oxygen. So ammonia is the 4, the oxygen is the 5, and the answer is C. Now don't get confused with D because they tricked you here and they swapped the oxygen for the ammonia. Remember, it is the ammonia to oxygen, so you have to write it in this order. For the final question, the question code's right here. It says when 50 centimeters cubed of a hydrocarbon CXHY was burned in excess oxygen, 200 centimeters cubed of carbon dioxide and 250 centimeters cubed of steam were produced. All volumes were measured under the same conditions. What is the molecular formula of the hydrocarbon? So basically, the question is asking what is the X and Y of this hydrocarbon that makes something CO2 plus something H2O. Now, although we weren't given the coefficients, we were given the amount of each that was burned. So we can just substitute that in instead. So we have excess oxygen, so this number doesn't matter. We have 200 of CO2 and 250 of steam or H2O. Now, we need to find the carbon and the hydrogen. So what we can do is we can multiply the 250 by the 2 and get 500, and then multiply the 200 by the C right here and get 200. Now, what this is going to do is that we have to equate whatever number is here because it says 50 centimeters cubed. So whatever 50 times x is has to give us the 200 carbons, and whatever 50 times y is has to give us this. So 50y is equal to 500 and 50x is equal to 200. Again, this is just simple math paper 1. So for this one, x is equal to 4 and y is equal to 10. So the answer is D. And yeah, that's it for this video. I hope you enjoyed, and yeah, see you in the next one.